Hello everyone, so we will be presenting the Pharma Botanical Research Project. My name is Hadil Darwish.
For those of you that don't know me, my name is Mark Viola.
And our mentor is Dr. Frank Ramdayal.
So the objectives for this internship were to extract and isolate substances from known plants, to identify and confirm these substances, to learn the methodology involved in the isolation and separation of the compounds, and to investigate the medicinal properties of a novel plant by isolating and identifying the compounds responsible for such properties. So the plant that we worked on was Ctenodinium grantica, or more commonly known as African milkbush. It grows in Africa and it is also cultivated in Brazil. And so what we did was we took dry leaves, we crushed them and then we ground them, and then we dissolved it using methanol solution. And we let it sit throughout the weekend so that it really dissolved into the solution. On Monday, what we did was we took out the solution and we attached it to the rotary evaporator, which is a great tool because substances found in plants are very heat sensitive and it can boil away quickly. And so this gently applies heat to it, only evaporating the methanol and leaving behind pure extract from the plant.
Okay, so using the extract, we had to test our solution. So the extract was tested for polarity using thin layer chromatography, which monitors the reaction. And we used a semi-polar solvent system of different concentrations of hexane, ethyl acetate, and methanol. And as you can see in the picture, only one of the plates showed a spot, which was it was the 50% methanol and 50% ethyl acetate. And this means that whatever compound or mixture of compound that's present in this solution is very nonpolar. But as for all the other plates, no spots showed, like moving at the top, because they're very polar. So the fact that it's at the top of the plate means that we can separate it. And that's what we did next. So what we did is we set up something called, we used column chromatography, and we started off by putting something called which is the stationary phase. We put silica gel with our solvent, which was the 50% methanol, 50% ethyl acetate. And then on the top, we added our mixture of reaction, but we had a problem that our compound or our extract was not soluble in the solvent that we had. So we added it to silica gel, which would absorb that compound, and we crushed it into a powder, and then we added it on top. And then after that, we started collecting a fraction of this, and we monitored it using TLC. And the first couple of fractions showed that we actually, the compound did come out of the column. And here you can see that we have 1, 2, and 3. It's not really visible here, but we have 3 different compounds. But since they are connected, this means that it's not really, it will be difficult to isolate, and that's what we are going to be working on during the next semester and in the summer. And now Mark is going to tell you about the second part of our internship.
So what we also did was we isolated limonene, and that's found in lemons and oranges. And what we did was we took the peel off by scraping them or cutting them off and scratching it, and we mixed it with water, and then we blended it together. And then that made like a mixture. And what we did to separate that mixture was something that's known as steam distillation. And we apply heat to boil the mixture, and the peel of the orange and the lemon stay behind, and the aqueous mixture, the water and the oil, evaporate and recondense into a different flask that you can't see here, but it's there. That is then separated, or we separate the oil or the essence from the water through something known as a separatory funnel. And as you guys know, oil usually tends to float on top of the water. So we open the valve and let the water seep out until all that's left is the crude oil from the fruits.
So we had to make sure that we did actually isolate limonene. And to do that, we did 2 types of testing. We started off with TLC to test the polarity. And as you can see here, this is the lemon extract and this is the orange extract. And they are both at the same level. This means that they have the same refractive index, which means that they're identical compounds. And also to further confirm this, we ran something called an IR. And as you can see, both of the spectras are actually identical, so this confirms that we actually did isolate limonene. And I'm gonna like pass around our 2 extracts and they do smell like lemons and oranges.
Or not. We'll leave it for later.
Yeah.
Thank you.